All right, folks, it's Bass Action back in action here. On this page of notes, what we're going to look at is how to transform an equation into its standard form for one of our conics so that we will be able to graph it in our later sections. The other thing that we want to talk about on here is how we can recognize what type of conic we would have before we even start our work, because that's going to guide us in terms of how we need to write our final answer. So let's look at our first problem here. And to determine what type of conic it is, what I'm going to do is I'm going to scan the whole problem and I'm going to look for how many squared terms do I have. And as I scan across, what I find is just this one squared term. So as soon as I see that I have this one squared term and only one, I know that I'm going to have a parabola. The other thing that I notice is that since it's an x squared term, that means that it's going to potentially cross the x-axis twice, which means that it needs to be an up-down parabola. Now, I'm not going to make a decision on whether it's up or down at this point, but just knowing that general direction will help us. Now, when I go to complete the square, which is going to be necessary to get it into standard form, you can see I've already pre-set up some things. For the squared term, I've left those two pieces on the right-hand side, the squared term and its linear term. I've moved the constant to the other side and collected it. And I've put a blank on each side as a visual reminder of, of how to keep my equation balanced. So on the right-hand side, to complete the square, to get this to be a perfect square trinomial, I'm going to look at this b value. I'm going to divide it by 2 and square it. So my negative 10 divided by 2 is 5. When I square that, I get 25, so I can put that in my blank. Okay. Then I'm going to balance my equation and put my 25 on the other side. Then I can write my next step, collecting my like terms and writing my perfect square. On the right-hand side, I'll get an x minus 5. That's the b value divided by 2 squared. And then I'm going to think about my standard form for a parabola, and it would say that the squared term and the coefficient need to be on opposite sides, and that's done. But also this coefficient that's on the opposite side needs to be factored out of both of those terms. So that means that that left-hand side isn't done. I'm going to factor out that 4, dividing each term on that side by that negative 4, which is going to flip this sign and make this a negative 3/4. The right-hand side will stay exactly as I have it, and that'll be my final form. In a later video, I'll talk about how to actually graph this. Let's move down to our next one. Again, we're going to first scan the equation and determine what type of conic we have. So as we scan that equation, going from left to right, looking for squared terms, once again, I'm going to find that I only have a single squared term. So once again, I have one squared term, but this time it's a y squared, which means it has the potential to cross the y-axis twice, which means this will be a left-right parabola. Just like before, I'm not going to worry about whether it's a left or a right. I just want to determine that general shape first. Now this one I've also pre-set up. I didn't have a constant that needed to be moved, but I do have a coefficient that needs to be factored out. It's important to remember that you're only factoring the coefficient out of the quadratic and the linear term. You are not factoring the GCF. So you can see that I've factored out my 2. Now I've put my parentheses and then I've put my blanks on each side. That visual reminder of those blanks is going to be really important to us. Let's take our b value, divide it by 2 and square it. That's going to give us a 9 inside the blank. When we balance the equation, we need to remember that everything that's in this parenthesis is multiplied by the 9. So we're going to take that 9, multiply it by the 2 to actually balance the equation and give us an 18. Now we can go ahead and simplify. So we'll have our x plus 4. On the right, we'll have our 2 times the quantity y minus 3. Remember, that's the b value divided by 2. Then we check for our standard form. The standard form says that our squared term and our coefficient need to be on opposite sides, which means I need to divide both sides by this 2 to get rid of it there. So now I'll have a 1/2 x plus 2. I don't want to, x plus 4 I meant to say. My brain was distributing it because I was going to tell you we do not want to distribute that. So we're going to have our x plus 4 there. And then we'll have on the right-hand side our y minus 3 quantity squared. So it's important to remember that we do not distribute this 1/2. We leave it outside as a coefficient. All right, last one on this page. Let's first determine the conic. So we're going to scan from left to right. And as we scan from left to right this time, we're going to find 2 squared terms. All right, those 2 squared terms tell us that it's definitely not a parabola. So we're going to have our 2 squared terms. I'm going to write it down here below my other note, 2 squared terms. And the other thing that I'm going to notice on those 2 squared terms is that both of the terms have the same sign. They're both positive in this case, but they could both be negatives, but they have the same sign and the same coefficient. Okay, the same sign and the same coefficient are going to tell us that this is a circle. So that means that when we're all done, our final equation should equal the radius squared. All right, now I've preset up this completing the square as well. I focused on my x terms. I grouped my x terms and my y terms. I did not have a constant that needed to be moved. My constant was already on the right-hand side. I factored the 10, just the coefficient, out of its linear and quadratic terms. I factored this 10 out of the linear and the quadratic terms, and I left the 135 alone. If everything had been divisible by that coefficient, I would have divided through, but in this case it was not, so I factored it out. So you can see I've put in all my blanks, and I put them on the other side as that visual reminder. So now, starting to complete the square, I'm going to start with this -2 on my x's. That's going to give me a 1 inside the blank. Balance the equation gives me a 10. In the next set of parentheses, my -4 divided by 2 squared will give us our 4. I meant to say +4 there, divided by 2. Squared will give us a 4. Balance the equation gives me a 40. Collecting all my terms and simplifying, I have a 10. X minus 1 squared plus 10 y plus 2 squared. Collecting all the terms on the right-hand side is going to give me a 185. Then, since my final equation needs to equal the radius squared, I'm going to eliminate these 2 coefficients that are on the left by dividing every term by a 10. So then on the left, I will be left with the perfect squares. And on the right, I'm going to reduce that fraction. Both terms reduced by a 5, so I'm going to reduce it down to a 37/2. And I'm not going to write that as a decimal. We're going to keep that as that nice improper fraction there. And that would be our final answer. On the next video, I'm going to talk about our other 2 conics, and then we'll also talk about graphing in some later videos.